Alrighty, so in this video, I'm going to teach you how to read a velocity versus time graph where the object is speeding up or slowing down or going at a constant velocity. All right, so the first thing that I want you to think about is the velocity versus time graph itself. And a lot of times the easiest way to learn this is to go ahead and put numbers on the velocity axis just to make it easier to talk about. So I'm going to go ahead and do that. So the first thing I want you to think about is if something was not moving, then my velocity is 0. So let's say at the beginning, at time of 0 seconds, it's not moving. So that would be a velocity of 0 here. And then at like 2 seconds, it's still not moving. At 3 seconds, it's still not moving. And so what I'm going to end up with is a horizontal line on the time axis or on the x-axis, depending on how you want to think about it. And that is when it's not moving. All right, so now let's think about if it is moving, but it's moving at a constant speed. All right, well, let's just pick a number. Let's say it's moving at 15 meters per second. Okay, so here's where 15 meters per second is. And if it keeps moving at 15 meters per second every second, at 2 seconds, it's still going at 15. At 5 seconds, it's still going 15. What I'm going to end up with is a horizontal line as well. But now my horizontal line is farther up. So this is moving at a constant speed. Next, I want you to think about if you are stopped at a stoplight and the light turns green, what's going to happen? Well, at the beginning, when you're stopped at the stoplight, you're going to have a velocity of 0. So at 0 seconds, my velocity is 0. And over time, I'm going to be going faster and faster. So let's say at 2 seconds, I'm going 5 meters per second. And then at 3 seconds, or 4 seconds, I'm going 10. And so I'm going to have a nice line like this. This is speeding up. And a lot of students want to tell me that it's a curve because they're thinking of a position versus time graph. In this class, we're going to only deal with velocities that are increasing at one rate. We're not going to have velocities that are increasing faster or slower at different rates. It's going to be straight lines. So our velocity versus time graph is going to be straight like this. And that just shows that you're accelerating or speeding up at the same rate the whole time. But what if I wanted to show that I was speeding up more quickly? Maybe I'm thinking about an old grandma getting on the freeway, and she speeds up really slowly. She barely pushes on the accelerator. And then I'm thinking about like the drag racer kid that wants to speed up really fast, so he slams the accelerator or gas pedal to the floor and he speeds up really fast. The difference is that if you want to speed up faster, you're going to end up with a steeper slope. So speeds up faster. So now that we've talked about these two different lines that are speeding up, both the purple one and the blue one, I want to think about it and go, hey, so what does the slope really tell you? And the slope on a velocity versus time graph is your acceleration. And I would define acceleration is how much the velocity changes each second. So that could be speeding up, or it could be slowing down, or it could be not changing. And all of those would describe how your velocity is changing each second. All right, so let's look at another one. I'm going to start here. And I want to look at all of these lines at 3 seconds. And I want you to tell me which one of these is going the fastest at 3 seconds. Look at it for a second. Now, your inclination might be that the purple one is going the fastest. And students often think the purple one is going the fastest because it has the steepest slope out of all of these. But that's not the case. Because if I actually wanted to look and see what the velocity is, I would take and I would look at this going sideways, and I would see that this is going like 26 meters per second, while the purple one is going like 18, and the green one is going 15, and the blue one is going like 8. And so the higher up it is, the faster it's going. The steepness of the slope tells you your acceleration. It tells you how quickly you're speeding up or slowing down, but it doesn't tell you how fast it's going. Now, this is a little bit of a weird thing because on a position versus time graph, the slope is velocity. But on a velocity versus time graph, the slope is acceleration. And in order to find the velocity, you just have to look at the dot and trace it to the left. Alrighty, and the last line that I want to talk about is this one here. What is happening when you have a negative slope? Well, for this, I'm starting with a velocity of 15 meters per second. I'm ending with a velocity of not moving because it's not moving when it hits that horizontal axis. So this then is slowing down because I was moving, I was going quickly at 15 meters per second, and then I stop. So this is slowing down. A lot of times students will tell me that this is going backwards. Well, a negative slope on a position versus time graph is going backwards. But on a velocity versus time graph, what happens is anything up here with a positive number is going forwards, and anything below the horizontal axis down here is going backwards because those velocities are negative, and negative velocities mean that you're going backwards. All right, so that's what you need to know. The slope is the acceleration. How high it is how fast it's going, and all of the rest of these, speeding up, slowing down, not moving, and moving at a constant velocity. Let me know if you have any questions.